Okay, so the recording is started. Lena, the floor is yours. Please go ahead.
Thank you, Vlada. So good afternoon, everyone. Welcome to our special session on supporting the democratization of data usage. I'm Leena Hallin-Pihlatie from the National Land Survey of Finland, and I'm hosting this session today. As Vlad already quite nicely explained all these practical things, and Vlad will act as the co-chair with technical issues, sharing, looking for the chat on WebEx and Slido. I will proceed to the topic. So the program of today is that after a short presentation that I will give to you, I will give the floor to the speakers from National Land Survey and from the Finnish Environment Institute and from Spatineo. We are all actually in the same meeting room in Helsinki, and all speakers have approximately 10 minutes to give their presentation. In the end of the session, we will have a question and answer part and discuss presentations. So there we will try to answer the questions that you have sent through Slido. But now a short introduction to the topic from my side. Last autumn, the Open Data Initiative in Finland turned 10 years. 10 years ago, it was a real struggle to find and to access and to use geospatial data without costs and long negotiations. Today, the situation is much better, thanks to the big efforts made by the Finnish data providers to make geospatial data and services available free of charge. These efforts have been backed up by the policy of the Finnish government, policies that stress the importance of sharing and using open data, policies that stress the importance of building digital solutions based on open source and the importance to digitalize services in our society. After this session, I hope that you will have an overview of where we stand in terms of geospatial data usage in Finland, what we have done, and what we still find important to do in order to support even broader use of geospatial data. The first speaker that I will invite to the speakers table is my boss, Panu Muhli, who is leading the Geospatial Data Infrastructure Services Unit at the National Land Survey. He plays a leading role in building a geospatial data ecosystem in Finland. Let's hear what Panu has to say.
Thank you, Lena, and good afternoon, everybody. And I'm really glad to have the honor of being the first speaker of this, I believe, outstanding session, which we are going to have this afternoon. So as you can see, the title of my talk is rather long and complicated one, and I believe the topic and the scope is also very ambitious. And I just want to emphasize the word towards. So we are getting towards an interoperable geospatial data ecosystem. And once we get there, I'm not even sure if we recognize the particular moments. But at least for now, we have a geospatial platform. So it's far from being complete and in full production, but we are getting there. And I think when I gave more than 2 years ago in an Inspire conference, sort of first talk of the forthcoming geospatial platform, which was in a very early planning stage. So I can now provide an update where we are heading for. So obviously, we would like to first make a question why we are doing a geospatial platform and what sort of ecosystem we are heading for. So, well, it's about money and economic value. 2 years ago, Spatineo published an investigation of the economic potential benefits of using spatial data. And according to the investigation, only 1/5 of annual benefits of using spatial data are actually realized in Finland at the moment. And the study also concluded giving a focus to 4 particular sort of ecosystems, thematic ecosystems, where spatial data is used in Finland. So the conclusion was that having a geospatial platform could yield €500 million annual benefits. Obviously not from the start, but when the ecosystem and the platform is complete and functional from 2025, roughly. So that's one reason, and another reason or driver for platform and ecosystem is a policy-wise driver. The Ministry of Agriculture and Forestry in Finland initiated and also carried out a report on spatial data policy, actually first of its kind in Finland, that was discussed and approved by the Finnish Parliament 1.5 years ago. And the report stated a very ambitious vision that Finland has the most innovative and secure spatial data ecosystem in the world, nothing less. So, of course, we need various measures to have to reach that kind of goal, to develop a common spatial data ecosystem and the platform to ensure high quality address information, to promote the knowledge and expertise on spatial data and so forth. The report is available in English as well. You can see a link here and download it and have a closer look. So there are very ambitious measures, but luckily we are not starting from scratch. We have as current actions, we have INSPIRE implementation for more than 10 years for building a national SDI, and that's also sort of backbone for a platform and an ecosystem. And we have this geospatial platform project running since 2018. So where we are now and what are the sort of components or elements of the geospatial platform? Data harmonizations is one key element. So we are going for data products, national data products from several sort of reference themes to have commonly specified data schemas, quality rules, life cycle, and also some guidelines for the collection of the data. So we have the services for the platform, both for data providers who can then upload the data to the platform and sort of central data warehouse, and services also for the users to deliver the data from the platform. And the collection of procedures and policies related to cooperation models, enterprise architecture, the openness as default, and also, of course, security and privacy issues must be taken into account. The main themes or the reference themes for collecting a common national database are related to buildings and addresses, and those are being implemented during the first phase in collaboration, not just National Land Survey, who is collaborating or coordinating the platform development, but all the data is collected and harmonized in collaboration with municipalities. And there are other themes as well, transport networks, land cover, hydrography, also compiled in full collaboration, and also some themes related to statistical and administrative units. So the services, as I said, are both for data users, such as sort of intelligent spatial data search to discover the data, to visualize the topographic data sets, also table joining service for joining statistical and area division data, and OGC API features as well for delivering the data using modern API services. And also services for the data providers who can upload their data sets, check the quality, make the harmonization, to validate the data using an Inspire validator, which is actually a national instance of this Commission ETF validator, and also a tool for collecting address informations. So large variety of different services providing the sort of key elements for the platform. One of the goals was also to promote the expertise and knowledge of spatial data, and that's why we also compiled an e-course called Better Decisions with Geospatial Data to really demonstrate for public servants and citizens what is geospatial data and why is it needed and what can be done with the data. Now this course published on a digital learning environment which is provided for the public administrations in Finland. More than almost 1,000 persons have been taking that course during the last year or so. So, well, we at the moment being still developing the platform, estimating the sort of value of the current pilots and current tools. We are definitely going to need some prioritization, so cutting off some of the services and giving the focus and efforts to those services providing most value to the society. So we are still going for and developing the APIs and services, going for the data production and maintenance tools, the quality and 3D sort of features of the platform, and in particular high quality address data is in main focus. So there's plenty of work for the next couple of years, and the work is still being coordinated and developed by National Land Survey in Finland, but in collaboration with many stakeholders. So the ecosystem is the goal, and as I said in the beginning, something we actually don't know exactly how is it going to be like and what will be the components of the ecosystem. But still we have the spatial data sets from the society, from different data providers, and we have the geospatial platform being a sort of enabler for the ecosystem. And the geospatial data ecosystem then provides a sort of intersection for different thematic ecosystems like built environment, traffic, bioeconomy, and so forth. And the ecosystem is going to be sort of operated in collaboration with municipalities, of course, government administrations, but obviously we need also companies to use the data and provide added value for the society. So that's where we are now, and I'm glad to answer any of your questions at the end of the session. Thank you.
Thank you, Pano. Our next speaker is Kaisu Harjo. She's leading the Geoinformation Services Unit at the Finnish Environment Institute. SYKE was among the first public organizations to open their geospatial data, launching an open data geoportal already in 2008. And to follow up the data usage and to develop the services, SYKE has carried out several user surveys, the results of which she will present to us today. SYKE is also one of the biggest data providers in Inspire in Finland. Please, the floor is yours, Kaisa.
Thank you, Leena, for introduction. My aim today is to present you what do we know at the moment about the users and use cases of open environmental data that Finnish Environment Institute produces. And like Leena said, we have shared for more than 10 years now openly. And I've prepared this presentation together with my colleague Riikka Repo from Finnish Environment Institute. So we'll start with a brief introduction about the background of open data in Finland, and then we'll have a quick look at the open data services of SYKE, Finnish Environment Institute, and then we'll get down to the actual business and see what do we actually know about the usage of open environmental data. Okay, so what's the background for open data in Finland? First of all, I have to say that openness of government activities is a principle in Finland. Actually, according to Constitution of Finland, every citizen has right to get information about government's activities. But for about 10 years now, there have been several initiatives and also governmental programs that has aimed to promoting for data opening. Open data programs and initiatives are led by the Ministry of Finance here in Finland. And I think that the expected impacts of open data are quite widely recognized and known in Finland these days. And these expected impacts are related to growth potential through new products and services that could be based on open data, and also cost savings and overall productivity. And of course, the transparency of the administration is one goal and positive impact of open data, just to mention a few. So like Leena already said, SYKE has provided open data already since 2008. At the moment, our open data services include quite extensive list of spatial datasets as downloadable files. We also have Earth observation products. We have environmental information systems. And also we have published different kind of network services and also web map applications to create different kind of access for these information assets. And of course, all of these data sets and services have metadata descriptions. And Inspire compatible view and download services are one essential part of our open data services, but we also provide kind of national versions of those view and download services. So what can we tell about the use of open data? We of course collect a lot of monitoring data, numbers of downloads of data packages, and numbers of requests to different web map services are monitored all the time. And here you can see some examples of our monitoring information. For example, how much our Inspire GMLs have been downloaded, how much have spatial data packages been downloaded, or how much are those Inspire compatible WMS services used in recent years. But we wanted to know a little bit more than the those numbers. That's why we have performed a survey twice to our open data users in 2017 and 2019. The main goal was to get some information, who are the users of our open data, what kind of preferences they possibly have, and for what purposes they use our data. And we did this survey together with Spatino. First of all, we wanted to know what kind of organizations those users represent. Are they from other governmental organizations? Are they from universities, enterprises, or where do they come from? Here are the results from both years 2017 and 19. And the results show that enterprises actually are the most active user group of our open data. This has actually been a little bit of a surprise to us, as we assumed that our open data would mostly be used by other public sector organizations, like governmental organizations, municipalities, and so on. And also surprising for us is the big share of citizens of open data users. Then we wanted to know which data themes are interesting to our users. What kind of data are they searching when they come to our portal? We picked data themes from our organization's strategic objectives and asked if they are interesting to the users of open data service. What we learned is that all these themes are interesting to data users, but data related to water, for example, to Baltic Sea, lakes, and water resources like groundwater bodies, seems to be most interesting to our users. But this result also reflects the selection of our data. SYKE has actually quite long tradition in producing different kinds of water-related data and information. So also this can be seen from these results. Okay, then we'll go to the use cases of open data. So what do the users have in their mind when they come and search for our open data? We made this kind of summary of use cases, which shows that data is used for different kind of decision making, first of all, and planning, but also for different kind of consultancy assignments, and also for research and education. But it's also used for different kind of information needs that citizens have. Let's have a closer look at these results. We don't have time to see all this in detail, but for example, citizens' information needs are quite interesting. They are overall they are interested getting some information about the quality of environment, but they also search information that they can use for participating in the development of their own neighborhoods. And also they use the data for planning their own leisure time activities. And enterprises, on the other hand, they use our data for maintaining and developing of their products and services, and also for developing completely new products and services. Some quite interesting use cases there. I will skip these and get to the conclusion. Okay, so as a conclusion, I could say that automatic monitoring information gives important background information about data usage. It's easy to get, and by collecting this kind of automatic information, we get to know that somebody actually is using the data, and we can easily interpret that somebody must also then need the data if they are using it. But survey results can be used for get more accurate information about data usage, and they show that open environmental data has many different kind of use cases, and also maybe results also show that open data has many positive influences also that are related to supporting better decision making and planning. And we can see that our data also enables the development and maintenance of products and services. It also creates easier access to environmental information for citizens, and also data is easily available for research and education as it's open. And we are really interested in developing this further, this evaluation of impacts of open data. And we think that for evaluating the real impacts, we need to combine these different kind of approaches, both automatic monitoring information, but also surveys and possibly also interviews. This is definitely something that needs to be further developed in future. Okay, thank you for listening, and I'll be happy to ask your, answer your questions later this session.
Thank you, Kaiso, for an interesting presentation. Let's go move further. And I'll invite Sini over here. Sini is the newest member of our team here at National Land Survey. She is responsible for keeping the National Inspire GeoPortal up to date with user interfaces provided by the data providers. Last year, the Inspire GeoPortal of Finland, also called Paikkatietotiekkuna, celebrated its 10th year anniversary. Today, we will learn how the GeoPortal is used in society in Finland today. And I could claim that the use of it can actually be seen as an indicator of the impact of Inspire. Let's listen to what Sini has to say.
Thank you, Lena, and very glad to be here. So, as Lena was saying, my name is Sini Pöytäniemi, and I'm maintaining the National Finnish GeoPortal called Paikkatietotiekkuna. And today I will be telling more about the users, their backgrounds, and also how they're using the data in the GeoPortal. But first, some basic background. So the GeoPortal name is Paikkatietotiekkuna, and you can find it behind this www.paikkatietotiekkuna.fi. The interface is both in Finnish and English, and also in Swedish. So also international guests are very welcome to come and try out the service. It's a place where the data producers can basically showcase the data, the Inspire data that they have, but not only Inspire data. So we are welcoming also any other WMS, WFS type of standardized data that we can set up in the GeoPortal. The GeoPortal is based on open source OSKARI framework, which my colleague Timo will be telling you more about after my presentation. So I won't go in detail too much into that. And today I also won't be telling too much about the tools that we have there, but basically with Paikkatietotiekkuna you can look at the data, but you can also, for example, publish embedded maps on an external website, and you can use it in 3D mode, and there's lots of different type of tools that you can use to do geospatial analysis also. So we have around 10,000 registered users and a lot more unregistered users, and daily we get around 3,000 users. That varies a bit, but that's the approximate daily. The use has been increasing every year since we started. So this is how the GeoPortal looks like. We have the menus and different kind of tools on the left side. In the left lower corner, you got the 3D, 2D switching button. You got different kind of panning tools, zooming tools and such, and scale bars, and so forth. But to the usage of the data. So here we have around 1,600 different data layers. They come from many different data producers. They are not all harmonized. They're not all Inspire, but around 1,600 different layers in total from around 60 different data producers. So here the size of the square tells how many data layers each data producer is having in the geoportal Paikkatietoikkuna. So for example, the Finnish Environmental Institute has quite a few layers there, but also many other national institutions have loads of data. But then some of the bigger cities, such as Helsinki and Tampere, are also represented here quite well. And as Leena was saying, so we celebrated our 10-year anniversary. So Paikkatietoikkuna was open in 2009. So last year we decided we have to do a user survey to see who are the users at the moment and what is Paikkatietoikkuna used for at the moment. We got around 1,000, nearly 1,000 responses for our survey. And here are some of the background. So the actual topic of today's lecture, what is it called? Presentation. So majority of our users are men, based on the survey at least. So around 80% of the respondents were male, and most of them are in the working age, so around from 15 to 65 years old. That's to put it very simple. Then their industries, mostly they come from a background of agriculture, forestry, and fishery. But then also research and different kind of experts are represented quite well there. And then also NGOs and different kind of hobbies. So in basically there is lots of leisure use also in Paikkatietoikkuna. So here also you can see that most of our responders have been using Paikkatietoikkuna more than 5 years, so they're quite committed to the use of our geoportal. Maybe also the survey got responses more from the more committed users, but anyhow, I think this is a great result. People are committed, and then also most of the users are coming to the webpage, to the portal, a couple of times a week. So that's pretty good as well. Some come there daily, some come monthly, and even some were there for the first time for the actual user survey. So here there is a graph for professional use. So these are people using geoportal for work. And here and in overall, in all the statistics, you can see that the land property data, so parcel data, property boundaries.
Ai nyt heräsit, kello on 3:30, niin sulla tuli nälkä, niin no se on hyvä, kun syöt.
Onko siellä jollakin mikki päällä? Voisi varmaan laittaa pois. Excuse for that one. I hope everybody will put their microphones off. Yes, I think. Okay, I will continue. So for the professional use, so we have around 71% of our users use it for work. And there the land property data is mostly used, but then also many use it for forestry and agriculture. Many use it for planning work, for field work, and also different kind of land use, environmental, building, architecture, infrastructure, planning, also private road matters and studying came up quite regularly. And then lots of different smaller uses came up also. So when it comes to the leisure or non-professional use, so 55% of the respondents use it for the non-professional use. So it means that quite a few are using it not only for professional, but they use it also on their free time. So they probably found out about it at work, but then also 29% of the professional users are using it for other purposes also. And there we have the sport route planning. So people use it for planning routes for cycling or walking or running, hiking. And then, funny enough, many people use it just for fun. So it's basically they just go to the site and look for different kind of data and see what is available, try the tools and find out new things, which I think is a very good thing. People are exploring what it can be used for. Then hunting, fishing, different kind of nature hobbies, berry picking and such is also used in historical study or hobbies. Okay, my slide changed. Then when it comes to about the functionalities that people are using, so we have here the basic viewing as the most popular use for the geoportal, which is expected also. So people are just placing different data on top of each other and seeing what comes up. But then people are also using a lot the measuring distances and areas tool, and then also just looking for place names, places, searching for different data. Then also other different tools such as the topographic profile tool are quite popular. We also collected feedback and ideas from the users. So basically here is just a word cloud representing the words that come up mostly in the feedback and ideas. So of course the data is in the center of all of it. So it came up quite a lot. But then just after that, we have feedback about the ease of use. So we got still things to do to make the user experience improved. But then also the data producers were referenced quite a lot. So we have mostly data that comes from external sources. So we are actually working there in between the users and the data producers quite often at times. So it's not always, the feedback is not always related to the geoportal itself, but it's hard for the users to see that maybe we can't always help them with the data if it's not working, or there's something missing. So we get new ideas also a lot. Quite a few people were looking for or telling about new ideas for new features. So that I think is telling about their commitment to the geoportal also. So they find it useful already, but they would like to also improve it in one way or the other. So for example, the mobile use and 3D came up from there last year. We also asked for the simple school grade. So in Finland, that goes from 4 to 10. So we got a 9, which I think is very good. Not perfect, but it's already a very good grade for us, and there's still space for improvement. Some conclusions. So while many of the data producers have not been maybe harmonizing all of the data, also the ASIS data and everything that we have in geoportal, the 1,600 different data layers, are very useful to the end users already as they are now. So people are able to put lots of different data in the geoportal on top of each other, side by side and use them, and they get a lot of benefit from that. We believe that the Paikkatietoikkuna is benefiting the society widely in this way. And also in terms of professional use, which is quite extensive for Paikkatietoikkuna. So obviously we got from there indirect economic benefits from the service as well. And as is with Inspire services normally and should be, so data and time are saved, money and time are saved by bringing data together in one service, such as Paikkatietoikkuna. And here you can find us on Facebook and Twitter also if you want to follow us. And thank you from my side. Here are my contacts if you want to ask. And also I will be gladly answering any questions in the end of our session. Thank you.
Thanks, Sini. An impressive amount of use cases there. I would like to remind you all that we're using Slido. There has been some questions in the chat. That's also okay, but we would like to collect them all on Slido. Next presenter is Timo Arnio. He is leading the open service team at our SDI unit. And one of his tasks is to coordinate the code development of the OSKARI platform. And OSKARI is an award-winning open source framework for displaying and analyzing geospatial data. It's used by a high number of organizations in Finland and worldwide. From what I've seen, OSKARI is also fast to adapt to emerging standards, but I'll let Timo tell you more. Please, Timo, go ahead.
Thank you, Lena. So my topic today is OSKARI, open and collaborative. And I have about 10 to 12 minutes time. The topics I will cover today is just briefly about OSKARI. I'm pretty sure many of you are familiar with it already, but I will just go through with a couple slides what it is in a nutshell, so to say. Then a couple words about OSKARI community, a large community that we have behind OSKARI nowadays, and some words about what's new since last year, so approximately 1 year backward from this moment. What have we been developing? And also in the end, a couple words about what's coming next. So maybe in a 1 year time frame to the future from here. So let's get started. This is a slide I always show to everyone about OSKARI, so I'm going to start with this one. OSKARI in a nutshell. OSKARI is a tool for easily building multi-purpose web mapping applications utilizing distributed spatial data infrastructures. The rest of the bullet points I'm not going to read out loud, but I'm going to explain briefly. So as also Sini mentioned, the national geoportal in Finland is based on OSKARI, and that's where it all got started. And you can use it to create embedded maps on your own websites or external websites. Or you can use OSKARI to set up a kind of full-fledged WebGIS system or geoportal, if you will. We have 15 languages with partial coverage, and Finnish, English, and Swedish are 100% covered in our user interface. OSKARI has always been and always will be open source. You can decide which license you want to use if you develop it further. The same thing in a kind of more visual form. What is OSKARI about? It's always up-to-date data and software, and it all relies on the availability of web interfaces or OGC standard interfaces or other APIs that provide data, feed data to the OSKARI instances that we have. I should mention also that we support statistical data in addition to spatial data that we mostly talk about when we talk about geospatial software. And we also do support users' own data. Users may have their own old shape files or map info files or some other files that OSKARI supports. They can be imported and also updated via or utilizing OSKARI. So all of this is done by OSKARI. OSKARI handles the APIs and pushing data back and forth, and it runs in your web browser. So it's a browser-based solution or software. And what benefits does this bring to OSKARI or to the end users of OSKARI? Well, there are never any installations. You never have to install anything. You just open the web browser and open up the OSKARI that you want to use. When it updates, you don't have to update it yourself. Someone else will do it for you. And you just open up your web browser again, and you have the newest version running. As many of you know, we utilize spatial data infrastructures, so you don't have to download any data. You use the APIs built on top of your precious datasets. And this again, you don't have to download the datasets again when they update, so you always have the up-to-date data in your session or in your use. API integrations, furthermore than data, we can use different kinds of APIs, routing or geocoding or analysis, APIs, etc. We have a lot of APIs that we have built integrations to and that we can support already out of the box. And last on this list is sharing your work, so you can make your embedded maps, or you can provide a map link, just a quick URL you can share with your colleague, showing what the kind of map you made, or analysis, or thematic map, or whatever you used OSKARI for. So this is the basics of OSKARI. A couple things that make OSKARI a bit different than the other solutions. So our specialties, so to say, the integration to SDI, so spatial data infrastructures again. So from day one, OSKARI has been built to utilize the already existing services and upcoming services, especially via Inspire Directory, but also other ones, national SDIs in Finland especially. And well, naturally they are OGC APIs. We do support some other ones, or ArcGIS, REST, and some proprietary interfaces, but mostly we want to and like to support the open specs made by OGC. As I mentioned, we do support statistical data. A couple of APIs we have tested and have currently support for. Mapbox vector tiles we do support, and also web map service with the time capability. So WMST is supported with a nice user interface. And Lena mentioned that we are kind of fast to adapt new specs. So we have the support for OGC API features already, I think last year when it was still a draft. We already built some kind of support for it, and now that it has been finalized, we have a pretty nice support for it. And we have the embedded maps already mentioned once before, and something called RPC API, Remote Procedure Call API, that you can use to control the map once you have an embedded map on your website. And then some, I will talk about the features in a moment. But I'm going to move on first to the community. I made a new slide. We had an old slide that had all the organizations in the OSKARI community, but I realized that most of the logos were not up to date anymore, and some of the organizations had changed names, etc. So I made a new slide with kind of the main actors currently in the OSKARI community. So we have the big agencies and institutions from Finland, National Land Survey of Finland, naturally, Digital and Population Data Services Agency, Statistics Finland, Finnish Transport Infrastructure Agency, and some of the bigger cities, or let's say most of the bigger cities in Finland, Turku, Helsinki, and Tampere, are all part of the OSKARI community, utilizing or wanting to utilize and developing OSKARI further. So a couple of companies also, they're providing support and services for OSKARI-based solutions. So quite an impressive community behind software. So next I have what's new. So what we have done within the year or so. I was planning to maybe even demonstrate a bit, but maybe I'll run through the slides and see how much time I actually have at the end. So we had two projects last year. The first one was about 3D, enabling 3D data visualization with OSKARI instances, and here is a quick screenshot of the 3D mode that we developed. It runs on Cesium.js. Probably many of you have heard of the open source library for 3D data, and well, obviously it utilizes 3D tiles as the data format, and currently they can be fetched from Cesium Ion, the cloud-based service, or you can host your own 3D tiles server if you have such capability. And the difference in the picture is very slight. It is actually showing the shadows in the building that we are right now in. We are about in the center right in the corner image. Maybe I can show it with my mouse even somewhere here. And this is the shadows at noontime today. And in the right side picture, the shadows at, I think, at 6 p.m. today. So we have a nice tool that you can visualize and kind of visually analyze the shadows in different times. And all of this you can also embed on your own websites if you want. So also the 3D stuff is available for that. The other big project we had was taking into use React for building the user interface, and for that we did a new tool that I will actually show now. It's for layer management, so we can manage the layers offered via an OSKARI instance. So you have a kind of administrator user that manages the layer content. In this Finnish geoportal, like Sini mentioned, we have more than 1,600 layers, so someone has to manage that content. And this same tool is also in use for the end users. Obviously, they will not be able to delete or add or edit the layers in the service, but they can see what has been added. I hope you can see the pictures. It's divided into 4 stages. The layer management. So here, administrator user is actually adding a WFS layer to the instance, and starting with the API web address and providing some scale limits for the layer, when it's visible, when not, and visualization and other parameters, and in the end giving users the rights to view or publish the data that is being added. What we support as data sources here, already mentioned the OGC things quite many times. So web feature service 1.1, 2.0, and the new OGC API features, web map service, web map tile service, 3D tiles, map of vector tiles, and some of those proprietary ones mentioned also earlier. A lot of user experience improvements made to this one, error handling, adding several layers from the same service has been made a lot more faster, and access control in the last picture here has been made a bit more nice looking, and styling support. And the styling support actually was on the previous slide. I will show it again. So we also built last year a new web feature service engine and styling options for that. So now you can provide styling for web feature service-based data. Here we have road accidents in Finland in the year 2018, and I made the kind of more severe accidents red. So whenever someone was killed or was too unlucky to die, it has been made red on this map, and all the other ones are blue. This was the one I wanted to demo, but I'm not sure how much I have time, so I can still show it if I have. I can, okay, I get the thumbs up from Lena, so I can also show that. How many minutes do I have? 5. Okay, I have 5 minutes. Thank you, Lena. Before I show in the browser, I'm going to tell you what's next in OSKARI. So the next version will be released before midsummer, I hope. So in a couple of weeks, version 1.56, mostly containing user experience improvements and bug fixes. Also some performance improvements and streamlining the kind of code base. We have a kind of long-term goal of getting rid of old libraries and components that are no longer used or unnecessary. Coming after that is a small user interface refresh, sleeker look and feel. This is actually a project run by the community, and National Land Survey is not taking part in other ways except coordinating that project. So all the development will be done within the community itself, and we will only provide support for that. Something called announcement functionality. So notifications for end users and warnings. So if your service is down or if something is not working as it's supposed to, we will soon have a nice functionality to show announcements for the end users. And kind of a long-term plan, I mentioned version 2.0, we are planning for autumn 2020. So this autumn, getting rid of all the kind of older libraries and dependencies that we have. GeoTools, GeoServer, OpenLayers, obviously we want to keep up to date and as new as possible, and also replacing some old dependencies with some refactored implementations. For example, Lodash is a library that we are currently working on, trying to get rid of, so to say. After 2.0 release, more functionalities that we want to provide is listed in the last bullet. So filtering improvements for web feature services. So we also want to provide end users and especially administrator users functionalities to filter the web feature service content, so that if you have a service that provides, let's say, millions of objects or features, you may not want to load all of those at once, but you want to filter them and style them a bit more nicely before actually even providing them to the end user. And coming with the styling improvements, also we can provide the functionality that the end users can actually edit and save their own styles for web feature services and their own datasets as well. So that's something we want to develop further in the autumn. Now, if time allows, I will just quickly show the browser, which is not anymore open. So I have to open it again. Now it's here. So here is the example I was showing with the picture. So the road accidents, we can zoom in a bit. Now you're gonna have to look at the side of my face as I look at the monitor on my right. And small thing I forgot to mention, we also have built support for showing labels for features. So as I hover my mouse on top of these road accident points, I get some additional information on these accidents. And if I click it, I get even more information. So this is all of the kind of feature data related to that specific accident. And if I may still try here, and here is all the features. Here are all the features currently visible on the screen in a tabular format. So kind of many views to the same data, and we've built them a bit richer this year. Okay, I think that concludes my presentation. I have a last slide with some links, which I'm going to leave you with if I manage to do that after this demo experience. There we go. So thank you for my part, and please do try out the implementations and the links on this slide, and also the link provided by Sini. Thank you.
Thank you, Timo. And this now we come to the last presentation, and related to the support of geospatial data, how to use it with other kinds of data. So to support the use of geospatial data with other kinds of data on the web, and to make geospatial data more easily available and consumable by developers, National Land Survey are publishing its new download services according to the OGC API feature standard. National Landway uses its own implementations as well as pilot services developed in collaboration with companies. And a fine example of the latter case will be presented next by Sampo. Sampo is the managing director of Spatinea, a small company with strong Inspire and OGC expertise, a true spin-off of Inspire, you could say. And Spatinea will tell us how he and Lassi Lehto from the National Land Survey use the new model simplification rules, the UML to GML, to GeoJSON guidelines, and the OGC API features services to publish more easily consumable, harmonized Inspire data in the administrative and statistical units themes. And Statistics Finland also participated in this work. Sampo, your turn.
Thanks, Lena. The name of the presentation comes from the fact that we were developing services, Inspire services for the future, in the sense that there's not really a specification on how API features and GeoJSON should be used for Inspire services. So that's looking into the future part, but also, as you might know, the movies also go back in time to a simpler age, and that relates to the fact how some of the ideas in API features services is to make something simpler, something which is less complicated and thus more easy for users to use and take advantage of. So basically, we had a use case. We published services for both national and Inspire data for the administrative units and the statistical units. We used API features to produce the services. I'm going to show you a bit about how we produce the data, not going into too much detail. And then I'm also going to talk about the model simplification, which is a very key part in how we will be able to leverage GeoJSON and API features for producing the Inspire services or Inspire download services of the future. And then, of course, along the way, we learned a few lessons, and I'm going to go through them as well. So just a very quick roundup of API features and GeoJSON. If you're more interested in this subject, I recommend going into the next workshop today, because that's going to be all about API features. But this is a very quick overview. So basically, the idea is to make a new standard, a new OGC standard for accessing GIS information, which isn't so much looking into how OGC has been doing things before, but instead looking at how are everyone else doing things online on the web. So it's focused on interoperability with how browsers work, with how other internet technologies work. And another key part is the self-documenting APIs. The standard really stresses that APIs need to be human understandable, so that you can point your browser into a service and you can understand what that service does and what doesn't have inside it, but also be machine readable. And these are key compared to old standards, because if a developer bumps into a WFS service, they don't know how to use it from the service itself. They have to go and read OGC specifications to know how to use that service, and not only a single OGC specification, but actually multiple, because those standards will refer to another standard and so on, which from a standardization point of view makes a lot of sense, but from the developer, from the data user point of view, it can be very cumbersome, especially if you don't come from a GIS background. And it's important to note that this is not a replacement. OGC does not see this as a replacement for WFS. This is a much, much simpler mechanism of accessing data. It's another mechanism to publish data and to get users and developers to access the data. And it's also important to note that this is not just for features. This same schema, this same ideology is being applied to coverages, map tiles, processing, which were tested already in a test bed last year, but I would be very surprised if the OGC wouldn't go even further and start making simpler versions of many other service types as well. For what we did was basically, we got data, we used FME, we got data both from Statistics Finland and National Land Survey. We produced data from that, and from that intermediate data, we produced a Docker container, which had a PostGIS database and the server that is serving the data. And this was hosted on AWS. And I think this is one important thing when you're thinking about Inspire services, that you don't necessarily have to use your own infrastructure or have to have your own infrastructure to host it. Inspire data most of the Inspire data is open data, or practically all of it is open data. So there's really no barriers of entry on using cloud services, and especially for these types of services, which might be very rarely used at some point of time, but there might be a use case or a time when someone really needs it, a huge amount of it, and needs to access it very quickly. The cloud resources are easy to make scalable so that they can adapt to the load at the time. We also, or Lasti, built a small web client also to access the data as well. And then final note, the server that we are using is an open source server, which is developed by us and by Vaisala and the Finnish Meteorological Institute. So to create the data sets, this is mostly in Finnish, but this is only background information. What's important here is that we used many different data sources. We used online services, we used shape files and statistical data that was available through the partners' websites or was collected for us for this procedure. And depending on which data set, whether it's the boundaries or administrative units, different sets of data was required for that transformation. As the collection structure, by collection structure, I mean how the data is organized within the service. When a user comes to the API feature service with a browser, they're presented with a website that they can browse, and in that website there is a list of collections, and a collection is a group of data. In this case, we have multiple collections, which we have the Inspire boundaries, the administrative boundaries and units, the statistical units, and the national version of all of these. But also, there's different geometry scales. We created data sets both in the national projection as well as WGS84. And then we also had variations of certain data sets depending on whether we want to include the sea area of municipalities and other administrative units or not. And this was all built into the naming scheme. So in this example below, you can see SU statistical units, Inspire, 100K scale, WGS 84. And then also we made sub-collections which refer to a data set from a previous year. So we always have the basic collection, which has the current information, but then the users may also want to look at previous years of the same data set. There's a proposal, as I mentioned, there's no official Inspire TG spec at the moment, but there's a proposal on how Inspire download services should be implemented using API features. This completed during and after the project that we did, where these services were developed. So afterwards, we took a look at the draft and checked where were the biggest differences. It's important to note that the draft proposes that there is only one service for one data set. We had a single service with AU, AB, and SU. We don't have a bulk download link. That would probably make a lot of sense because, as we know, some of the use cases are truly online, and some use cases someone really just wants all of the municipalities in a country. And also we don't have multi-language support. But this was a prototype, it's working well, and it can be further developed. But then we come to the maybe the as important thing as API features, which is how do you map the Inspire data model into GeoJSON. And there was a MIG-T working group on this a few years back, where they produced these model simplification rules. So basically, how do you turn the UML into JSON? The group also produced some example themes, or mappings or schemas, if you like to call them, for addresses and environmental monitoring facilities, but they did not want to produce schemas for everything. And the model of working is actually such that you produce that you can use another schema if you want, or someone else's schema, or you can produce your own. They don't necessarily have to be equal, but you can also build on other people's work. The main problems: structural attributes. There's multiple values. The UML refers to different features. You have abstract geometry types and also mixed geometry types. The simplification rules, there's many, but we focused only, or we only needed flattening, primitive arrays, simple geographic names, and code lists. The slides here contain a lot of examples that you can look at, but I'm just going to go through them pretty quickly so we don't run out of time. Basically, this is now an example of what Inspire ID looks like in a GML encoding. So you have a element, Inspire ID element, then you have a base identifier, and within that you have a local ID, you have a namespace, you have a version ID. And the flattening rule flattens this so that instead of the structure, you only have names which refer to the structure, but you only have simple sort of a name and value pairs, but in XML. But then when you turn this into GeoJSON, you get a much simpler version. So you only have the Inspire ID local ID, Inspire ID namespace, Inspire ID version ID, and the values for them. So this is already much simpler than the original. Then primitive arrays, as we know, GML many times you need to have a method of referring to multiple values for something. So this is an example of the lower level unit in the administrative units. So which units are lower to this particular unit that we're looking at. And when this is flattened into GeoJSON, we get a much easier to read list and also much more informative and easier to understand for the developer. This is much more in line with what you would see normally with API or REST services on the web. Then we have the simplified geographical name. So this is quite a handful to read. The name is a very complex thing, and of course we know things have multiple names, different names for different reasons or for different cases. But in the end, what the user really wants is a name. If we need this complexity, you can always go to the GML. But to hand this out to a developer and say, well, just grab the name from there, is very difficult for a developer to understand. So in the end, there's a Finnish version and a Swedish version. And in the end, we only have a name in Finnish, a name in Swedish, and then of course the same in GeoJSON. So this is going much simpler. We are reducing information, yes, but in most cases, someone might argue that in almost every case, this is what the user and the developer actually wants. Then we have code lists, very similarly. We have a national level first order, then a country and a code list reference and the value is actually twice in there, and we can simplify that into just two fields with single values each. So basically, this is what looks Finland in GML. So the administrative unit for Finland in Inspire GML, not very beautiful in this case. It's just raw text as it is. If you compare that with a GeoJSON format, that's already, it's a lot less text and it focuses really on the content. So we created the schema for AU and SU because there weren't no previous schema proposals, and those are available if someone wants them, of course, for others to build on. These are the different administrative units that were covered and the statistical units that were covered, and a nice screenshot of the tool that Lassi built, which shows the sea boundary version of municipalities in Finland, which you can see are quite complex, and it still works very well in a browser. So lessons learned very quickly. I'm running out of time. So funnily enough, when Inspire is trying to do harmonization, there are some cases where there isn't really harmonization between the themes. So for example, in administrative units, there's a name, and in statistical units, there's a geographical name. So some inconsistencies there, something that might be interesting to take a look at when we really start building the GeoJSON schemas for Inspire datasets. It's also very important to know that the property schema for the GeoJSON is really important, because through the model simplification, you can get a much more readable result. And it's much easier to understand, much easier to digest in the applications.
but it also relates to how the actual API calls are done. So in API features, when you're referring to making a filter, you are referring to the property schemas, etc. And that makes a big difference in how you have named things and how easy it is to use. Feature geometric complexity is a somewhat problem. There's different levels of detail. Some require different levels of details, others much coarser, and there's no real specification on how to do this in API features. There isn't one in WFS either, but considering that we're trying to get services that are usable in the web environment, it's really important that the developer doesn't have to figure out how to simplify a huge polygon when all they want is like a rough outline of a country. And then the CRS extension for API features is not yet complete, which resulted in us doing different collections for the different projections. Then we have some links to the data sets. And as I mentioned, this works in a browser. You can open that in a browser and look at the service through there. That's it. Thanks.
Thank you, Sampo. And then we have all the presenters have presented, and then I will ask Vlado to have a look in Slido. Are there any questions there? There are some few that I have collected from chats.
Not for the moment. I will put my screen with Slido if it's okay, Lena, with you, and you can go through the chat questions maybe.
I'll go through the chat questions. There's a few to Panu. Yes, if you could come over here, Panu. Some of those were already addressed. The question was if there's an open version of the platform to try, and the address was already provided. But something more you would like to say?
So there's the beta version of the platform services currently available, open to anybody interested. It's only in Finnish, but we are currently in the process of translating at least some of the main components of the platform user interfaces in English. And we have a Twitter account for the platform. I'm not sure if anybody has typed it in the chat box.
I have shared it on the chat.
Good, so. Perfect. So following the Twitter account, you will be informed during the summer period once we have the English translations available. And maybe another sort of perspective would be an open, meaning open source. That's something we are considering at the moment, whether it be useful for some users to have at least some tools or components of the platform also released as open source. So not yet, but it's being considered. Yeah, funding was already answered in the chat. And is the platform usable for the emergency services? I would say not the platform services themselves, but the data content. So that's one of the primary goals of the platform program, to provide nationwide high quality address information with good coverage, not just building addresses, but also, for instance, waypoint and entry level, more detailed addresses as well for instance, emergency services. So the current platform services are not really optimized for emergency services, but the address information will be available for emergency services. Okay.
Thank you, Panu.
That's it. Thanks.
Let's move further on the questions on the chat. There's one question that perhaps Sini and Kaisu could answer, related to the question that was asked, if you know if the professional users access the data, how they access the data. Professional users, do they use open APIs, or do they rather download the data? do you have some remarks?
If the question is related to paikkatietoikkuna, so I have to say that from there you can't download spatial data at the moment, so you can download data in a table format. So in our case, people are using APIs most of the time, even if they didn't want to. So in that case, professional users are using a lot of the different Inspire and not Inspire data through APIs.
Because the GeoPortal is kind of based on all of the APIs
Yes,
and the
that's-
services, so that's what they are all
Exactly.
using. Yeah.
Exactly, that's what the GeoPortal is based on.
Thanks.
Based on APIs. But maybe the Environmental Institute has a point of view to that one.
My experience is that professional users they use both. They like to download the data files, but they also are able to use those web map services and WFS services. So I think it depends on the use case. If they are doing some kind of heavy analysis, spatial analysis, then they prefer to download the data.
Okay. Yeah. Thank you. There's one for Timo here. Question related to how the Finnish Heritage Agency how they are using the OSKARI platform.
Yeah, thanks for the
If
question.
you could open. I have a look at the chat in between.
Yeah,
There are
please
some new ones.
do that. Good question. They have, I think, several services running on OSKARI. They have a kind of general map service which you can use to find different sites that have some kind of historical value, and I think they also do data collection utilizing OSKARI. About that part, I'm not 100% sure, so you will have to check that on their own webpage. So they do have a nice webpage though, some time ago updated, so go ahead and have a look from there.
There is actually one more now.
One more,
related
okay.
to OSKARI, so I'll ask you to
I'll
stay.
stick around.
The question is if which metadata platform you are using today.
Today,
Is there a link to GeoNetwork, for example? Or
yes, we link to GeoNetwork, but you could use any that provide the catalog service for web, CSW API. So currently in Finland we use GeoNetwork.
But in OSKARI you always use the
API.
The API.
Yeah,
so
so the
in that
catalog
way you
service
can
for web
use
is the one
any
that
kind.
we use. Yeah.
In the GeoPortal, it's mainly the GeoNetwork then that is used.
Yeah,
because
in the Finnish context, we use GeoNetwork.
Yes. Okay, thank you. And then there's one for Sampo and did you already have a look at the question?
No, I didn't see the question yet.
So GeoJSON does require to make data flat. Would JSON LD or JSON schema, in your opinion, provide capabilities similar to XML XSD to provide complex biodata?
To be the contrarian here, I think if you look at the goal, I think the main goal of API features is to have something very simple, to have something immediately understandable to a developer, to a web developer. I think going for JSON LD or requiring using JSON schema would make things very difficult. Also, some of the working mechanisms in API features specification might become a bit difficult if you're using sort of complex feature or a structural data in the GeoJSON, because you need to be able to refer to fields. So I would say it's possible, but it might not make sense. If you have more complex use cases, it might make sense to just use GML. I think Lassi is agreeing with me.
Okay. Yeah, thank you. So we still have 5 minutes for questions. I think it's also okay to raise your hand, and or if there's no questions on Slido, then we can just do it the other way. That if you have any questions, please put it on the chat. Or so there's another one. So yeah, a comment. WFS will be around.
Yeah, at least that's how OGC sees it, and I tend to agree. I don't think it makes sense to push all the complex features of WFS into API features, because then we would end up with having too complicated service types, which both of which might be good for complex things, but might not be good for simple things, and that has been the official line from OGC that I've heard. So because, well, as you might know, WFS has the stored queries, it has very complex filtering mechanisms, etc., which are really difficult to use, but when you need them, they're great. But when you don't need them, you might use API features. That's how I see it, at least.
Okay, thanks. Some new comments?
Yeah, Torsten.
Torsten to Paul, okay.
So I'm guessing, Torsten, your presentation is done for the next workshop. Yeah, of course, GeoJSON can be as complex as you want to, but I think especially to make the API features API as simple as possible for the developer to use, having a more complex feature type could be useful for reading, but not be very useful for querying. When you have to make a query to the server and you have to refer to a property in the objects that you want to filter on, it might become a bit complex if you have a very complex GeoJSON structure in the schema. I say schema because it's not necessarily a schema. It's an open API schema, but it's not a JSON schema.
Yes. Thank you. Well, as Athena just pointed out, there's the next session is focusing on OGC API features. So, and we actually have a colleague of ours giving a presentation there on exposing Inspire addresses using API features and GeoJSON, Jari Reini. So this was kind of a bridge to the next session then, and there's some chat going on there, but I suggest that they are related to the OGC API features, that you will continue the discussion in the next session. So at this point, I would like to thank all the speakers here in the room, and to all participants for being present and for asking questions. Thank you, everyone, and have a nice week and Inspire conference. Thanks. Bye.